衝啊你啊！block
Got smash it.
I don't know what
the
happened.
bottom
I think it was a little dent down there. I was like, shit. Everyone watched the video like, wait, you must have TMP box.
Okay, guys, please check our answers. If you have any questions, please ask because this chapter really requires some explanation, especially for those who do not know what's going on. Please check answers for the ABC part first, then after that, we'll go through the answers on the paper 4 parts, alright, guys? Starting with question number 1. Question number 1A. Question number 2, boy. Question 3, donkey.
Hey, you should look at my answers, man. I don't know if they're right or not.
Question 4A, 5A, and 6, boy.
Wait, 3 is what?
Question number 3 was donkey. 4A, 5A, 6, boy.
Oh, boy. Wait. Shit.
Okay, before we proceed, anyone has any questions or not for the first 6 questions? Question number 3.
No.
Okay, very good question. Okay, guys, look here. Like I keep saying over and over again, the idea is that current will always flow the path of least resistance. Today, right, what happens is if today this switch is closed, means to say it's connected here, right? Before the switch was closed, the current flows like this, right? Because it didn't have a choice to flow alternatively, right? But as soon as the switch is closed, when the current flows until here, it will choose to either flow here or flow here, which then it realized that, hey, this path is the path of least resistance. So it will totally bypass the resistor and only flow through here, meaning to say, instead of having 2 things, right now the current will only flow through 1 thing. Meaning to say the current is going to be higher because there's less resistance.
Then should the answer be A? It goes more bright. Why is it D? Why is it the brightness doesn't change?
Very good. The answer is wrong. The answer is supposed to be A. It glows more brightly.
It was just a test R moment.
It was a mini test.
It was a
You
test
pass.
R moment, bro.
You pass. Yes. Oh, wow. I thought. Okay. Let me print it out for you right now. Okay, who's messaging me? Question 2, what's the answer again?
B.
Boy.
Wow. The day you give me potato juice, the day of all some. You're gonna drink like your average European kid. Okay.
Shit, it was 6. Oh shit, oh yes. Oh yeah！ 等一下，我们全部拍照 ，OK？
个嘛，6个，9、7个，然后总共8个。
Oh yeah！
Oh yeah！
Oh yeah！ Okay, anyways, back to this.
Yeah, I'm gonna think about it. The pink pants fiction.
Okay, guys, anyone any questions for the first 6?
First thing, wait, let me see first. Oh yeah.
I think it's printing already. You wait outside and you get it.
Question
as
6.
I feel you get it.
Question 6.
Question number 6.
Oh.
Okay, what's this? The diagram shows a potential divider. So there's 6 volts here and 0 volts here. When brighter light falls on the light dependent resistor, the resistance changes. Guys, in these scenarios, the first thing I like to do is I like to identify that there's brighter light, right? It means to say the light intensity increase, right? What will happen to the resistance of this light dependent resistor? Decrease. It's always opposite of each other. Remember, light dependent resistor and thermistors, they'll always be opposite of each other. High light, low resistance, low light, high resistance, high temperature, low resistance, low temperature, high resistance are always opposite of each other, right? What happens to the resistance of the light dependent resistor? What happens to the current? And from here, once again, we understand that R is equals to V over I, right? When my resistance decreases, what will happen to my current?
My current will.
It will increase because these are inversely proportional. These are directly proportional, right? So from there, your answer will
Oh,
be
that means I think I got it because I misunderstood. I thought it's proportion. What directly proportional.
if they are on the same row, they'll be directly proportional. If they are in the opposite row, they'll always be inversely proportional. Okay, guys. Yes. Question number 4. Which combination of the parallel resistors has an effective resistance of 0.5? So in order for it to be 0.5, I have to once again use my formula, guys. 1 over 1 plus 1 over 1, which will give me 2 over 1. This is not the final answer because this is only RT over 1 ma. So in order for me to get, this is going to be 1 over RT ma. Right. So in order for me to get RT, I have to flip this thing around, which will get me 1 over 2, which is going to be 0.5. So my answer is A.
Right.
Anyone else? Good. Moving on. Check your answers for these ones. If you have anything wrong or you don't know how to do, please make sure you ask again because once again, this series and parallel circuit chapter is a bit annoying. Yes, Anas, I can see a question moving in. What? B3. Is it related to any of the questions above?
B3 is the last one now.
Oh, it's all related.
Yes, it's connected.
Calculate the current in 55 ohm. So I want to find out how much current is here. Okay, guys, once again, because this is in series, it means to say however much current there is here, it will be however much current is in the 55 ohms. Okay, so in this scenario, there's three cells, right? So here is 4.5 volts. Try to label your diagram because for me, I find it much easier and I need to find the total resistance here is how much, right? Which is going to be 1 over 60 plus 1 over 30, which is going to be 3 over 60, which is going to be 20 ohms. Here is a total of 20 ohms, right? Plus this thing together will be a total, the total resistance will be 75 ohms, right? Right? Then from here, I will be equals to V over R, which in this case will be 4.5 divided by 75. Press that in your calculator, you should be able to find the total current, which will flow here as well. What do? Do you do something different? 4.5. You cannot do 4.5 over 55 because if you do 4.5 over 55, right, assuming all the 4.5 volts is only transferred to here, which in reality this 4.5 is here and here, you get what I mean?
Wait, so I use different method.
It's okay for series circuit and parallel circuit. There's multiple methods. You don't have to follow my method, but you, as long as you get the right answer, is good enough. What's the answer?
0.060.
Guys, why is it 0.060? Why can't I write it at 0.06 as my final answer?
3 significant figures.
Minimum 2 significant figures, maximum 3 significant figures. Meaning to say, if you wrote your answer here as 0.06, right? It's not volts, it's amperes. It's not good enough, guys. As you can see here, you see, they actually have minimum 2 significant figures. You need 2 of it. Okay. Any other questions for this one? Good. We move on.
I am going to speak on quiz for space physics.
I can't help you for that one, but don't worry.
I can't see me anymore, because when teacher.
I can send you some videos. If I see I got videos or not, they just watch.
Is it hard actually?
There's a lot to memorize. For chapter 6, space physics, is the most things to memorize.
Because right, my teacher asked us to make a project on thing.
With them in mind.
I don't even understand what I'm typing, man.
Check answers, guys, for the next one. 6, 48, 16. Anyone has any questions? Huh? Oh, the whole thing, ah. Okay, we'll go through the whole thing. Oh, okay. So you see, these kind of questions, right? There's parallel and then there's also series. So what we want to do is we want to simplify the whole diagram first. First and foremost, if I look at this scenario, I'll combine these two to become one resistor, which is actually going to be 48 ohms, right? And then after that, I need to combine these two things together, right? Which is going to be 1/48 plus 1/24, which is going to give you 3/48, which will give you 16 ohms at the end of the day. Okay, do you manage to get to 16 ohms? Oh, okay. But am I going too fast? Do you know what's going on? You can, So the first thing I do is I combine these two series to make it 48. Then after I combine these two parallel to make it a total of 16 ohms. Okay. Then after that, they say, the battery consists of 2-volt cells in series. State the number of 2-volt cells in series for the battery. So how did I make up to 12 when I only have 2 combined together? It's basically 12 divided by 2, which will give you 6 batteries. 6 2-volt batteries will give you a total of 12 volts. You get what I mean? So you have to put 1, 2, 3, 4, 5, 6 all combined together to get 12 volts. So that's your first answer. Good copying. Okay, then after that, they ask you to combine the resistors of the 2 resistors in series first part, which we did already. It's just these two combined together. Series is just plus part, so you get 48. That's your first answer. Then they ask us for the total resistance in the circuit, which is when you combine the series and the parallels together, which you'll get 16 ohms. Okay. Okay, everyone else? Okay. Yes, proceed to the next one. Check answers for the ABC, guys.
I think I cannot wrong because
Don't tembak way.
I think tembak, I just like look at the thing like 这样子 like 我没有 tembak 那玩，我只是 tembak 因为我不确定罢了。
Question 1, boy.
We can explain
How do you get donkey? Question 1, boy. Question 2, boy.
I say this one. I know. I haven't settled.
Question 3, donkey.
Oh yeah. Question.
Boy, donkey.
Donkey. 我们当我什么？我是 donkey.
Anyone? Cannot understand.
Question 1, 2, and 3.
Oh, also cannot. Let's go.
Let's go. Hey guys, first and foremost, when you look at this diagram here, this is what power supply? You see this squiggly snake thing? What is it called? Wow, no one knows what this thing called. So you guys will look at this diagram blind, basically.
Isn't this like the power source of?
Yeah, what kind of power source is this?
Beats me.
Yeah.
Higher. Wave. Magnetic wave.
Shut up, What is this? What kind of power source?
Constant power.
What's that called? Very good. Alternating. AC power supply. AC power supply means to say it's alternating current. How is it different from direct current, guys? Direct current, which is like your battery, right? Your battery will only flow in one direction, right? But for alternating current, it will flow in one direction first. Then after that, a second direction. Then again and again and again and again.
Like the base, like the
base.
like I remember last week is this one.
Yeah. So first things first is you need to identify that this is an AC power supply standing for alternating current. Yes. So if it's an alternating current, means to say the first cycle will flow here, the second cycle will flow here. So if I see the first cycle which flows here, this is forward bias, right? So the current can flow, right? So there's current. Okay, there is current. Then after that, the second cycle when the current flows like this, can flow or not here? Cannot. Then it will be flat lah. Then the third cycle flow again. Oh, can. Then the fourth cycle flow again. Oh shit, cannot. Then okay, can. Cannot. So answer is why. Okay. 34. The diagram shows a current with a fixed resistor connected in series with a thermistor once again. Straight away, when you see the word thermistor, you need to know they are opposite temperature resistance, which row shows how the temperature changes affect the resistance of thermistor in the circuit. Temperature decrease, thermistor decrease, wrong. Temperature decrease, thermistor increase, probably.
Correct.
Increase, probably, increase, wrong.
No, it's boy.
Huh.
Life is boy.
So from here, if my resistance increases, will my current increase? No,
No.
it will definitely decrease. So answer is boy, because this one decreased resistance means to say more current should flow, right? So this one is wrong. So answer is boy. Wait, you got refer to the notes one or not?
People inside here.
Okay, and finally, last one, identical cells and identical resistors are used to make the circuit. Circuit 1, the ammeter shows 2 amperes. What is the ammeter reading in circuit 2? Okay, I know the confusion here, guys. You're thinking like, shit, I don't have any other information besides 2 amperes, right? But your information here gives you that it is identical cells and identical resistors. Means to say it doesn't matter what number you put in, as long as you put in the exact same number, right? And if you look here, let's say for example, here's 5 volts. Shit, 5 is not a good number.
4.
10 volts. Then this one will be 5 ohms, right? For it to match, right? So like V equals to I times R, so it will be 10 to 5. With this as a base, you can put the exact same values on the next one. But right now, is it still going to be 10 volts? It will be 20 volts, 5 ohms and 5 ohms. How much?
Then it'll be
4.
4.
4.
A 不是5加50，对
Okay, if you're not certain, you can do it the manual way also.
4.
From here, you need to find out the total resistance.
2.5 because it's parallel.
Yeah, 2.5 law, which is actually just half of it, right? Then I'll find the current here, right? I goes to VOR 20 over 2.5 press in the calculator, you get 8 amperes. Okay. Remember, guys, if you're uncertain with the values, just put dummy numbers that will make sense first. It doesn't matter what number you put in as long as you satisfy these 2 conditions. It doesn't have to be 10 now, it could be literally any number, guys. It can be any number as long as it satisfies these 2 conditions. Okay, guys. Yes. Good, excellent. Moving on to the next part. Check your answers, guys. Anything you don't know, I'll explain.
The total current limit of 983 volts. Very yummy. Same. I do like it. 4.5 like 2 is 15 to 5.3. Very yummy answer.
Guys, I want to repeat this again since everyone is already here. When you come back from Merdeka that week, we're going to do a test 4.1 all the way until 4.4 are in your notes. Hey, sorry, 4.3 only. Okay, 4.1 until 4.4. If we finish the exercise today, it's with time. If not, then it will be 4.1 to 4.3. Oh, weird. 4.1 until 4.3 for now, but if you finish this early and I can continue my notes, it'll be 4.4. Oh yeah.
Ask every question.
Sure, every question don't know how to
can I like
Oh, time
don't time D, don't have to spread it so much. Yeah, so this one understanding is more important than moving on. Yeah.
Hey, you guys started school already, right?
Yes.
What are you guys doing in school right now?
Huh?
Space. Why do space one so weird?
They skipped the student.
Then I write the presentation or something.
I also don't know writing. I just copy from the notes only. I see some
See the font. What is that?
so it's like it's like the it's like basically it's velocity equals like the d over t one, right? Speed equals distance over so it's like one variant of it for like I think it's like where it's like speed equals to like 2 pi something over t1.
2 pi r is because it's moving in circular motion. It's just circumference of the orbit only.
It's 2 pi r over t, right?
Yeah, it's actually the base understanding is speed equals to distance over time, but the distance is in a circular motion, and that's why it's 2 pi r over time.
And speed of light is 9.05 times 10 to the power of 15, right? Is that
9.05.
my brain is like so fried, right?
3 times 10 to the power of 8, bro.
But because I saw the presentation, I saw the notes, it is wrote there 9.05 times 10 to the power of 8. I'm not lying. I can show you my notes. I can show you the notes that teacher gave. That's why I wrote there.
Of that in Star Wars or what?
I maybe in Star Wars some notes. because I'm looking at it, I'm like, maybe that's what it is. What it is.
No, man. Actually, right, if you look at it, for space chapter, I didn't exclude anything. You can refer to my books here. For speed of light.
Speed of light is how it's
for
like
the space chapter. It's all already there already. So you can refer to my notes. There's no empty spaces. It means that. 7 more minutes, Johan.
怎么他这样迟到了 recently?
No, say got tuition.
I thought he live very near here one. Like both his house also near here one.
Okay, guys, any questions for this one? No.
Every question. So I can do 10A1, 29A1, 2, and then yeah. Okay, then.
Hey, seriously, any questions for question number 9? No questions. Settle.
A1's voltage are good. I wonder.
Okay, we've got no questions. Then we proceed with the next one, guys. Oh, you guys done?
Yo, what the fuck is a diode, bro? It has down or something,
You don't know what's a diode? We just literally talked about it.
Is it the
Literally.
Arrow thingy.
arrow? Oh, that's that. I don't know the name. I know what it looks like, but I don't know
Not
the
diode, bro.
diode. Oh, diode. Okay.
Diode.
Diode. You trying to be French? It's called a diode.
Diode.
Diode. Trying to be French? I know some French too.
You know some voltmeter?
Voltmeter. Yeah. A voltmeter isn't that like the popular dish outside?
Okay, I'm done now. This question.
I think we have something.
Any questions? No, I really move on.
Yeah, I think we have to stop being racist, bro.
Diode allows current to flow in one direction only, my friend.
Imagine physics had like an oral test and diode. So if you connected diode to the voltmeter, we
Usually when you go to uni or college, you will actually see these kind of lecturers.
Hey, Mr. How you did this?
buzzer,
Oh,
like Buzz from Brawl Stars. Yes, I'm taking every chance to make a reference to anything possible.
Okay, straightforward.
Mm.
Last one. Quick answers.
So Mr. LED light. LED. This actually like my first time I ever like actually know how to say like how my whole life I never knew what LED actually stood for, you know.
Yeah, you do.
Because every time I think about LED, I just think, oh,
That's
light.
white.
I think white light. I see LED, I think it's white light.
Everything in life is white light. Man, I want to others like RGB stuff.
So how do you use this one?
Now which one?
R1.
Relay. What are you gonna say? How else can you relay? Yeah. How else do you
Relay.
relay? But that's wrong one.
So yeah, I remember that. So you know how you say artifact last time?
Artifact.
You know how you say artifact last time?
I remember because it's so dumb.
Artifact.
Yeah, pronounce it so badly because
It's not British,
I know I'm not British, man. I said it because I was I forgot why.
Hurry up, don't just talk with finish
Okay.
writing.
I just need to finish this part.
Guys, anyone don't know how to do any of this question? Like for example, 9A2. Nine A2 guys can do what?
Hot voltage.
If hot or cold voltage across the thermistor will be high or low.
Actually, I can't really, can you explain 9-2 to me? The answer scheme doesn't make any sense. I don't even know what
Yeah.
this shit even means.
I'm wondering when will you guys ask me already?
Because
I tell you, if no one asks me this, right? I'm gonna point at one random person that I know for sure cannot do it, and you're gonna answer me. But someone has already saved you guys.
Yes, your angels are here. I'll be for them.
The circuit can be used to indicate a change in temperature. State and explain what would be observed when the temperature changes from hot to cold. Basically, the temperature decreases, right? When the temperature decreases, the resistance will what?
Increase,
right? So what's going to happen is when the temperature increases, guys, this is what you need to know. This thing here is a light emitting diode. And light emitting diodes, there is a minimum amount of voltage it needs before it starts blinking, guys. So let's say, for example, before the temperature change, maybe the temperature was high and the resistance was low. Let's say in this scenario, let's say this was 10 ohms and this thing, let's just say this thing was 100 ohms and this thing has a total of 10 volts here. Yeah, not 100, maybe 90, easier to distribute. Okay. In this scenario, before the temperature dropped, guys, what's going to happen is this 10 volts will split how much voltage to here and how much voltage to here.
Nine and 10.
Yeah, 9 and 10 volts, right? I mean 9 and 1 volt, right?
Oh yes, I see.
Right.
Not nothing.
Right. In this scenario, this LED only has 1 volt. So maybe it did not hit the threshold, the minimum threshold for it to start blinking. Okay. Then right now the different scenario changes are. Oh yeah. Oh yeah.
But what size of
XL.
not XXL?
You think they have XXL?
Guys, one thing I forgot to mention just now, when this thing had 1 volt, guys, because this thing, okay, everyone pay attention, look in front, stop looking at him, pay attention. When this thing has 1 volt, because this thing is in parallel with this thing only also had 1 volt, that's why it didn't meet the minimum threshold, it didn't light up yet. But right now, with the same conditions, this one is still 10 volts, this thing is still 90 ohms, and then right now the temperature drops. Okay, when the temperature drops, the resistance increases. Let's say the resistance from just now 10 ohm increases to 90 ohm right now. Right. So right now this thing from 10 ohm becomes to 90 ohm. Right now the voltage distribution will be different, right? How much voltage and how much voltage?
5V.
It will be 5 volts each and 5 volts each, right? If this is 5 volts, that means to say this thing will also get
5 volts.
5 volts. And this is when the light starts blinking. Because it meets the minimum threshold for the LED to start blinking out.
Wait, so A and B has to supply like the same amount to meet the threshold?
No. I'm just giving you an example only. There will be a certain threshold you need. But the idea is that because these two are in parallel, when this thing has a higher resistance, it will draw more voltage. When it draws more voltage here, it will draw more voltage here as well.
If you draw more voltage, that means like it will hit the threshold and this thing will start blinking, right?
Yeah, correct. So like just now, the first scenario, it was 1 volt only, right? Maybe it didn't hit the threshold, so it doesn't blink at all, right? So when this, in the application for these kind of things is when the temperature drops too much, the light will start blinking. For example, maybe you're in a, you put this in the refrigerator, right? And then you put a specific kind of meat, which is like Wagyu A5, whatever, which can only reach at, you can only eat, you're supposed to store it at 0 degrees Celsius. Then after that, the freezer malfunction and the temperature drops like crazy. If the temperature drops like crazy, then after that, this light here will act as a warning signal that the temperatures is dropping beyond the threshold. This is one example of the application, guys. Alternatively, if I put this light here, it will be a different application. For example, wow.
I don't think I want to be an engineer anymore, man.
There'll be a totally different. I'll draw you the other scenario when the situation arises. But depending on where you plug this LED, you're going to have different functions, guys. Okay, anyone don't understand what I'm talking about or want me to repeat myself, I can repeat again. It's quite a concept to grasp. If you don't understand, it's going to be hard later, especially when we do past year papers, guys. Anyone wants me to repeat this?
Yes.
Excellent. Okay, I repeat again. So before the temperature drop, let's assume the temperature is high, right? Temperature high means to say resistance is low. This is my first understanding, Let's assume here is 10 volts. The initial split of voltage was 9 volts here and 1 volt here because higher resistance get more voltage, Yes. So because this thing is connected in parallel with this thing, if this guy gets 1 volt, this guy will also get 1 volt, which is actually not enough for it to light up. There is a minimum threshold for LEDs to light up. Okay, so right now the situation changed already. Right now the situation changed in the sense that now the temperature drops. When the temperature drops, the resistance will increase. And because it increases, right now the voltage distribution will be different, right? Here we'll get, let's say 5 volts. Here we'll also get, let's just say 5 volts. Right, because higher resistance draw more voltage in a series circuit, right? So if this thing gets 5 volts, then this thing will also get 5 volts. When it receives 5 volts, for sure it meets the minimum threshold already. That's why the LED starts blinking. So this thing here, this LED here serves as a warning signal that the temperature is too low and it will just start blinking. Like maybe your car engine also has the same thing, right? Your car engine can't run on cold, Do you guys know? Some of the foreigners, when they start the engine, it's not like Malaysia. Today you start the engine, then can start straight away drive, right? In colder countries, people start the engine and they have to wait in the car. Why?
To warm up.
Yeah, the engine needs to warm up. If the engine runs on coal, it will actually smash the engine much faster and you'll have to go pay for the repair and everything. So maybe this thing here can be placed in the engine also, in the sense that when the temperature is too low, the light will keep blinking, telling you that don't drive yet. If not, your engine will blow up into 1,000 pieces. This is one of the applications.
You want to die, start driving.
Yeah, so some people they're kanchiong one, even not cold countries, some people that work in Genting, I see the same thing also. Because when they place the car in Genting for too long, right, because the temperature is cold, right, obviously the engine will start to get cold also. So some people, as soon as they start the engine, right, they'll just wait there. They'll wait for the engine to heat up. Then, Malaysians, as soon as you see the light start turning on, you start waiting there and you put signal, right? Then this guy is waiting for the engine to heat up. And I just tak, 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 and I can see from the back mirror more and more people waiting already. Because everyone is waiting for this guy to engine heat up, then reverse out, then only I can park in. You get it? So this is one of the applications when the temperature is too low, it will give a warning signal.
Okay, that's a good explanation now.
Do I need to repeat myself?
If you want, can.
I don't want.
You got can because
Because you know, I really don't want to do the exam with another topic, right?
no, it's fine. Go. We want to listen to it.
Okay, everyone, understand? Which part? Which part? Say until understand. Which the distribution of voltage? Is it? So right now the temperature decrease, the scenario is the temperature decreases, right? When the temperature decreases, the resistance is going to increase. Right now, when the resistance increase, because these two are in series, higher resistance means to say a higher voltage. It doesn't necessarily have to be 5, it could be even 1 and 9 here right now. But I know the threshold is met already. When the threshold is met, because this thing is connected with parallel with this thing, then this guy will get the same voltage. Same voltage, then you start to light up. You start to blink already, the LED. Yes, confusing chapter. I know you're not the first one.
So basically, the voltage is the way it's right.
So from here you have to state and observe, My statement is the LED starts blinking up, LED. Wait, what? LED starts blinking or starts lighting up, Then I have to explain, I have to explain why, right? Then you say, when temperature decreases in the thermistor, the resistance increases. Since the LED is connected in parallel with the thermistor, more voltage is drawn with the LED. That's how going along these lines, like the super simplified version. Not next week. Next week after Merdeka.
you got CUTF camp or?
Week after next week.
What I know. I just go home and I just rewatch the video. I asked her for the video. Actually, what I asked, I have the video. I just didn't finish watching the whole thing yet. I just faster go home and watch myself. Space physics, they got count for our midterms one, the cooked up. And you guys got assessment of space physics or not? Because we have a.
Always in your class one,
Yeah, I'm talking to you. I'm not talking to you. I'm talking to you. I'm talking to you. Not you guys as in you and Java.
Here going for braces.
Is it the obvious?
very slow.
Is it the obvious? Oh my god, it is really obvious.
Yeah, this is a common sign that they'll go for braces because they want to make space. Fun fact, guys, for if later on you have kids, right, and you want your kids to have not go through braces, right? Usually people have crooked teeth, it's because their jaw don't have enough space to hold their teeth. So what my wife's parents did when she was young, right? She brought her to the dentist, and the dentist straight away saw that, oh, your jaw is not going to have enough space to hold all the teeth. From young, we'll just plug two teeth on top and 2 teeth at the bottom. So when the teeth start growing outwards, right, it actually had enough space to slowly grow upwards, and the teeth is actually straight also without braces. But it's a different story for everyone. For me, my teeth is relatively straight because my jaw is big enough to hold all my teeth. And also my 2 wisdom teeth is actually growing out like this one. So it had enough space. If my wisdom teeth grew down like this, it would have pushed all my teeth and it will be crooked also. So next time when you guys have children, bring them to the dentist. and then the dentist will know whether the jaw has enough space or not.
You give your children the superb jawline, right? Superb jawline.
Okay, moving on.
It is a dentist, like he starts using physics on your children's teeth, right? Or in your stuff.
Okay, last part. Check answers for the ABC first, guys.
What?
Question 1A. Question 1A.
Xiao, what happened?
Question 2, donkey.
Why so mad? What happened? Yo, what do you guys
Question
do?
3C.
Yo, what did you guys do, bro?
4 boy. 5A. 6A. And 7C.
Yo, how is 7C, bro?
1, 6, 7.
1, 6, and 7. Oh, same thing.
Same here. 1, 6.
The circuit diagram shows a fixed resistor and a thermistor used in a potential divider. VR and VT of the resistors are R and T respectively. What happens to VR and VT as temperature increases? So right now, the temperature increase here, right? Resistance will. When resistance decreases, the voltage will
Increase.
decrease. So if this the voltage decrease means to say there's more voltage distributed to this, right? And thus your voltage is going to increase, right? So what's the answer? Is my answer wrong?
Let me see.
Answer is wrong once again.
Oh, test again.
It was a test once again.
It was a test R moment, bro.
Yeah. Oh shit! Bro, the temperature decreased, bro.
Ah, you failed your own test.
I failed my own test, guys. I'm not qualified.
Bro, so I get packing, bro, kind of go back to kindergarten.
Actually, I'm just a college student, and I've been half-assing you guys all this while. I don't know what's going on.
Anytime I'm actually kindergarten student now.
Temperature decrease, resistance increase, and voltage increases. Guys, means to say the voltage here is going to decrease because this thing right now draws more voltage from here, and there will be less voltage to be distributed here. So your VT is supposed to increase, and your VR is supposed to decrease. Answer is A. Did I confuse anyone just now? Sorry, I didn't read the question properly. It was the temperature decreasing, not temperature increasing.
That's in college and already married.
He skips some steps in life,
Many steps.
Maybe it was an accident.
The club accident, bro.
Okay,
The part of 97.
and what was the next question again? 1 then?
He said 1, 4, and 6, right? Yeah.
4.
6, 7.
1, 6, 7.
Number 6, what's this? Oh, something similar again. How about you tell me how to do this right now?
Every single month.
Light is falling.
Now is increase.
Oh shit, the light falling on now. Light increase.
Fuck, I mean resistance is decrease.
Yeah, so light increase, resistance, decrease, voltage.
Decrease.
Oh,
Hey, wait, what? Is that
No.
okay?
Yeah.
Oh yeah.
so resistance, decrease, voltage, decrease.
Hey yo.
Question number 5. Guys, by the way, I want to emphasize this again. This thing is used to rectify alternating current into direct current. Do you guys still remember how it works?
Somewhat. And you remember, okay,
Yeah.
let me try. So right, the first one, right, you go from the plus, right, go through R1. You
Then
go
go
there,
up, go middle.
go through the middle, go up. Ultimately, and then we go from the negative one. We start from negative. And go up,
Middle.
middle,
Down.
and ultima. Oh, guys, we're so bad, guys.
Which statement is correct? There is a current in R and a current in R2. Yeah.
Well, number one, AO.
Yeah.
I damn correct.
Sorry? Oh yeah, actually this is a DC power supply.
No, my because he said DC power supply goes from like one then the other, and then
But it'll still go If it's DC power supply, means to say you're positive to -5, it'll still go.
it will, Marcus, like
But there'll still be current in both scenarios.
exactly.
You see this one here, the flow is go through here already, right? Then go through here, then go through here, then go through here, then go through here. What? There's still current here and there's current here also. What? Just that they are opposite direction. One the current is going up, one the current is going down only. There'll still
That's
be
what I
current.
say on my toilet.
It's not DC. Sorry, I didn't notice. If you see just plus and minus is a direct current power supply.
I see.
Yes.
I use my toilet now. What good? So flash, right? Like the shit of the events inside the house. And then it came in some drainage.
Sorry, say that again.
You know, shower.
No, it's not. It's not a point. It's the flow of current that is allowed to go, because of these diodes, right? It kind of controls where the current is flowing. I cannot flow through here, you know, because it's a reverse one, and I cannot flow through here also because it's a reverse bias. So the current can only flow through here, then down, then here, then here, then here. This is the flow of current.
Good.
Next question.
Goody.
487.
Wait.
DVD 4.
Just because I got 4 wrong doesn't.
Same thing again.
Yeah, same thing again. I
Tell me how to do
like,
it.
Okay. So basically, hear me out. It's called this name of this circuit, type of circuit is a variable resistor, and the name of the device is a fuse. It's just 名字吧嘛，这个 because variable
It's a fuse.
yes, no man.
Hey God.
What dumb? No wait, no. Is it a thermistor? Sorry. Not fuse. Bro, my bad thing.
It's for sure. Hey guys, one more way to identify whether it's thermistor. You see this hockey stick in the middle? Remember, hockey stick is a thermistor, guys.
Baby.
Yeah, Canada. Thermistor, guys. So, name of this circuit, potential divider. Because I'm dividing how much voltage is here, how much voltage is here. What was the next question again?
7, last one. Hey, so he's asking the questions, not me.
This one you don't know how to do. How to do? What are you looking for?
Energy.
What's the formula for energy?
And ABIT.
Oh, so you find the VIT, right? What's the V? What's the I? What's the C?
A.
What?
Oh, I know already. You don't have time, but you're given one more information. Read the question properly.
Oh, you get the 8A,
Well, I
right?
think it's what is that word? This one.
Coulomb, but I don't know.
Coulomb.
I don't know lah, same shit lah. Same shit lah, whatever lah.
Hello?
Camera.
Hey, 1 coulomb of. Hello? 100做咩事兩個粒波啊？你成日都兩個粒波噶嘛？你喺 Adam 嗰度係咪？你喺 Adam 嗰度啊？我教到5點喎，一樣啦。你 call 佢啊？OK，OK，嚟。
Continuous writing, bro. I don't know.
Ew.
What?
Okay.
Just rubbing my finger.
So, everyone, what does 1 coulomb of charge mean? What's the formula for coulombs again? There's 2, right? What's the formula?
看我什么？
You. What's the formula for coulombs? For charge? There's 2 formulas. Give me one.
C times L times B.
Anyone can save this poor soul. C times L times D. I don't know where he conjured this equation from. What's the formula for charge, guys? Very good. Q equals to IT is the first general formula. The second one, eh? Yeah, Q equals to ME.
Holy shit.
So in this scenario, what you're supposed to do is you're supposed to identify that this thing is the same as this thing, which is the same as this thing, and you're going to identify that E is equals to V times Q, which in this case here will be 16 multiplied by 1. That's why your answer is going to be 16 here.
With the 8,
Ignore useless information.
or
Because they give you 1 coulomb already, right? This is 1, right?
so the 8 is a trick only,
Yeah.
right? Wow,
Yeah, the 8 is going to be there to make you look for the T for a long time just to find no answer.
頂你個肺啊！有用啊！
Okay, guys, any other questions?
I think I'm going to settle the
Okay, finally, the last part.
actually what's inside this food, but actually
Some snacks and some sweet.
actually I see the Australia.
Yeah.
You went to Australia?
Which one? Melbourne.
Oh, no wonder you are talking about
Melbourne is the best, baby.
Hey, you know what? I agree. My cousin lives there. I agree. And my gogo going tomorrow. He's going alone for 1 month.
Oh yeah.
Alone.
Yeah, he's going alone with my not alone now. Like he's going to go there live at my my auntie's.
Answer.
This
Hey, this one
To
draw one.
2 lamps is
Hey.
like 6.
Wow, didn't even attempt to draw.
Attempting.
Oh.
Hey, bro, 2 lamps are connected in parallel. Literally, this one is. Wow, I cannot accept anyone that didn't get this one right, bro. You're literally not reading the question, and you get your mark already.
Hey, you know like the toilet guy, right? Like, you know what happened, right? So apparently, like the Asian, we hired the Asian helpers, right? The plumbers, right? No, those are the agents, right? They hired like the cheapest plumbers. They confirm to save money, you know. Then right, ended up right when we flush the toilet, right? The shit water is supposed to go down to the system, right? In a way, you know, like the longgang, you know where you shower is a longgang at the side one, right? The shit water came out from there, you know. And then right, my whole bathroom is filled with shit water, you know. I don't even know how that happened, man. No, not my mom's. But I don't even know how it happened, bro. Like, this is not even
It's actually not a plumber's fault. These days it's been flooding in a lot of parts in KL, right? You know when there's flooding, usually the toilets the shit water will come back on because they can't go down.
It's definitely a plumber's fault because like one day, right, I was opening my freaking tap water, right? The water didn't come up from the tap, you know, it came up from the roof, you know.
So singing the water fountain, you should. The water fountain.
But you know, like, you know what I used a shower head, right? You know, it's a rain shower, right? Open the rain shower, the water came from the roof again.
Okay, so you know the water fountain looks got light. The answer, don't talk anymore.
No, I'm dead serious. Stop bro. This actually happened, you know. Like I'm so pissed about it.
The farmers will get sick, bro.
You know what the guy say? No refunds. Yeah, I don't know this guy. I want to beat his ass, man. Like, actually, like I this guy is actually damn retarded, like 真的。这世界上不应该有这些人呢。
You know Johnny Sins better.
Actually, I genuinely believe Johnny Sins will do a better job than him. I don't even know if Johnny Sins knows how to use a plumber. Wait, he definitely does. No, if he knows how to use a plunger, he definitely does. He's bald. He definitely knows.
Okay, any questions for this one? Quite straightforward lah. Just apply the formula only.
Johnny, the agent.
Yeah, the agent they wanted to like cut costs. The dumbass Asians, they hire some like dumbass.
Last question, guys. Check answers. Finally, we are done.
I'm not kidding, they hire some like bum-ass people, bro. Like, these people are actually bums, and they got a 15-year-old working on our toilet, bro.
Actually,
Yes!
You see? 你看你多幸福，15岁已经要做 toilet 了。
yeah, but then the shit water flying up like water fountain like that.
Hey, they got some bums to work on our toilet, man. It was so sad. And there's nothing I can do about it.
Which one is it?
So you're so 15-year-old, you want us to make shit fountain or not?
You should get your place lah.
Fucking, bro, so fucking ads, bro. Potential performance.
You know, Subway.
Okay, guys, you have successfully dragged my time to not so long. New chapter coming. I guess you only go. Okay, I'll give you guys some things to focus on your notes, guys. Open up your notes. I'll tell you what to focus on. Don't fail my paper, guys. We will talk shit about you with your parents.
I just asked this time, bro. Hey, your son's a something.
God!
Oh,
80 and above.
Wow.
Starbucks.
the threshold so high right now.
Wait, where got high?
Very
Okay lah, 75 lah.
Oh. Now I'm interested. Now I'm interested.
75, okay, guys. Exam only want a copy.
Boss,
It's not obvious.
monetary gain. No, that's a very defined motivation to like keep going.
Everyone, welcome at the first chapter here, guys. You won't have time to copy, just pay attention, copy from your friends. The first thing I want you guys to notice, shut up. First thing I want you guys to notice is how the magnetic field goes. It will always go from north into south, guys. If you get this one wrong, congratulations, you are special, my friend. Okay, you have to know the difference between ferrous and non-ferrous, basically magnetic and non-magnetic. You also need to know what is induced magnetism, guys. What does the word induce mean again?
Okay, good question.
Create, right? So whenever you see the word induced magnetism, imagine this is an iron bar and this is that magnet. When I place that magnet onto the iron bar, this iron bar here will start exhibiting magnetic properties in the sense that if I put paper clips here, it will be able to attract. But the magnetic field will always be opposite. If this was north, here will be south. And if I slide the magnet all the way to the other side, this will be north and this will be south, guys. They'll always be immediate opposites of each other, right? You also need to know.
I was gonna ask you that this magnet, right? Like, is it actually, why does it like make it like, why does it make the metal?
Okay, very good question. Because this magnet is actually flowing its magnetic field line onto the iron bar. So you can imagine these invisible magnetic field lines, they are flowing through this iron bar right now. And because this iron bar allows the magnetic field to flow through, then this thing will start exhibiting magnetic properties as well. Okay, next. You need to know the difference between permanent magnets and temporary magnets. Obviously, is steel and iron because of its properties, guys. Go back home and read it yourself. Don't score less than 75, are you? Okay, then this is extremely important, guys. This part here basically says that whenever there is a current flowing through a conductor, it will induce a magnetic field. And when there is a magnetic field, can you imagine this magnetic field is flowing through here, and then finally back here, right? And once again, the magnetic field is touching this iron bar, right? Which means to say this iron bar will become
an electromagnet.
Yeah, an electromagnet, guys. It will become an electromagnet, guys, because the magnetic field is touching the iron bar. And of course, if I have a strong magnet, you'll know that it has damn a lot of magnetic field lines. And if I have a weak magnet, it will have much less magnetic field lines. Right. This part important. Make sure you know how to prove not only the pattern of the magnetic field, but also the direction of the magnetic field. Pattern is when you sprinkle the iron filling, then you can see the pattern, right? Direction is when you place the compass on the pattern, guys. Right. Hey, where's your notes? Okay,
So
yeah, read through this on your own later. This one also important. When there's a current flowing through a conductor, using your right hand grip rule, this thumb represents the direction of current and these four fingers represent the direction of magnetic field. X represents the current going in, dot represents the current coming out. And based on whether it's in or out, you can tell the magnetic field lines. You can tell the direction of the magnetic field lines, guys.
So when it's in, it's opposite to it.
Cross. You can determine using the right hand grip rule. In, out, in, out.
So let's say like I'm swinging a question, so it's like in and then out, out.
So you don't do like that way, you just do like this way. It'll be your paper will be in front of you, in will be X, then you know that it will be flowing clockwise, the magnetic field.
And out will be like this.
Yeah, out will be like this. Then you know the magnetic field is anti-clockwise. Okay. Yes, yes, yes. Copy. Okay, then this next part is electric field. Electric field is similar like magnetic field, but instead of magnets, it's charges, and there are only two charges, positive or negative charge only. This part is important, guys. You better know how to define what an electric field is, which I've said multiple times. By placing a small positive charge, it experiences a force outwards or inwards, guys. Remember this part here? Right, if you don't remember, I'll quickly draw that the scientists, how did they prove that the magnetic field, the electric field is going out is by placing a small charge here. And it got pushed outwards. When put a small positive charge here, it will get pushed inwards. That's how the electric field came to be, guys.
How the fuck do you place a charge though?
It's a scientific experiment. But the definition is here, guys. This one, important. Make sure you know. Okay. And this one also relatively important. You guys still remember this?
Yes.
Right. Basically, you need to know how you need to know when to remove, which one to remove first, the earth wire or the rod first, guys.
You remove the earth
Earth wire first, then you remove the rod. Okay. You can refer that here, guys. For those who need to refer, it's going to be your answer here. I think that I gave you guys an answer for this one. So you read this, this one will come out, guys. I can guarantee it. So you better know what to read, guys. Okay. Then after that, maybe some form of this calculation will come out also.
Maybe
You should know, maybe, I don't know. You should know how to do that. Maybe this one is relatively important, so you need to know how alternating current and direct current works. This one is for sure important. You need to know the direction of current flow and you need to know the direction of electron flow, guys. So make sure you know that. This formula also is important. Make sure you know this. No, it's not. It's the opposite. It's like friction and movement. They're the opposite direction. And make sure you know how to define the electromotive force, guys. Important.
Some stuff is important.
Yes.
Everything is important out here. That sums it up. Everything is important. I think
this one for sure important. You better know the difference between ohmic and non-ohmic. What's the difference again for ohmic and non-ohmic conductor?
One is directly proportional.
What's directly proportional?
Straight line.
Very good. Constant resistance. And this one will have what resistance? Increasing or decreasing?
Increasing.
Increasing resistance. If I have a I versus V graph, it should tilt towards the V. This one for sure I'll put it there. This one. I won't ask you about the graphs, by the way. You remember that week when we were doing the comparisons of the long and the long and the short resistors in terms of the factors, right? I'll put something similar like this in.
Or the calculation.
Yeah, you need to know how to compare when the wire from short to long, what happens to the resistance, when the wire from small to big, what is the resistance, guys? So yeah, what's the formula for resistance of a wire again, which I asked you guys to write down? R equals to
R equals to L.
LA. Right, this one important. Make sure you know how to compare, for sure come up.
L is what already? Length, right?
Yes, my friend. Okay, these three formulas, important, for sure come up.
Well, actually, chapter is that
Oh yeah.
I'm gonna guess motor chapter. So I think I guess 75 will be getting 75 will actually be a freaking miracle, bro. Because like
75 Starbucks time, boys. Make me spend my money.
actually no, it's actually a miracle. I'm not kidding.
Okay,
Hell.
and this one no need to say lor. For sure come out, but it won't just be like this. It will be like what we did just now.
Wow.
Make sure you know how to.
I don't want to live anymore. This soul.
Yes, please refer to your exercises, guys. It's going to be important.
Oh, then can you like you sent me the 2 weeks of this first 2 weeks?
I sent you everything already, I think.
Everything up until here.
Cannot. It will be a good balance. It will be probably 10 questions of multiple choices and maybe 5
5 out of 10.
5 to 7
5 to 5
I think it should be
5 to 7
0 to 5 something.
And make sure you read these guys. Make sure you know how the resistance works, how the diode works and everything. Yes. That'll be all for today. Good luck, all the best after Merdeka.
Well, I'm telling you, I'm gonna study so much. I feel like I'm gonna